Okay, greetings guys. So this is what's happening in the Tech Relief lab. I was trolling Amazon and online to have a look at some little logic analyzers, and I came across these guys here from on Amazon, and says 2-piece USB logic analyzer device with USB cable, 24 megahertz, 8 channel, blah blah blah. Anyway, I thought to myself, how good can they be for I think they said $17 now. I think I paid less for them when I bought them a month ago or so. And one of the reasons that I was interested in these is that I was a cheapskate and I bought an oscilloscope with only 2 channels, which I regret. I should have got a 4 channel one. And I want to be able to look at more channels. If you look at logic circuits, you often need to look at more than 2 signals at the same time. And so then I got the idea, well, if I had a logic analyzer, then you can get 8 or 16 channels or whatever. In any case, I got these guys, and let me switch screens so we can discuss this a bit further. So what I've done, amongst this tangle of wires and this mess over here, I threw together a simple little circuit with a BCD counter and a 7-segment display on it to see what it is counting at, and I've got that hooked up to my oscilloscope and also to the little logic analyzer, which is actually over here, which we'll have a look at in a minute in detail. And let's switch to the oscilloscope and you'll see why a logic analyzer is a good idea. So I've got this set to a very slow signal right now because it's counting, like 1, 2, 3, that sort of thing, almost 1 a second or something like that. And the signal generator that I'm using is at that low speed. As you can see, that's the clock signal up the top, the yellow trace, and it's not actually a proper square wave. Somehow it's suffering. But let's so this is another reason why a logic analyzer is a good idea, because it will actually capture the signal and tell you whether it's being interpreted as high or low. And if it is a bit of an analog signal like that, then the high and the low can be in different places. But let me switch it to a higher frequency so we don't have that aberration there. Okay, so we've got this running at just over 5 kilohertz right now, and now you can see we have a proper square wave at the input. And I got the second probe, the purple one, connected to the output of the BCD counter, so it's actually halving the frequency from what the clock is receiving. Anyway, so what we have here is, even if you had an oscilloscope with 4 traces or more, then it's still not quite as convenient, as you will see, as having a logic analyzer, because in order for me to know if there's any offset between those traces, you would have to, adjust the time base, and you would have to then go and, if you want to know the timing of the signals, you'd have to set up some cursors and tell it to measure between those cursors. Of course, if you've got an old-fashioned oscilloscope with a CRT-based oscilloscope, you probably don't even have those facilities. You have to do it by eye. So let's talk about switch to the logic analyzer output. Okay, so interesting thing here. I have an older PC which I built, I think probably nearly 12 years ago. When I built it, it was top of the range, and it's got an i7 processor in it and so on, and it runs at about 4 gigahertz clock speed and all that kind of stuff. But nevertheless, it uses an Asus motherboard, PX97 something or other. In any case, it has some components on there, USB port, AS Media, and some other brands, and none of those seem to be supported very well in Windows 10. Recently had Windows 7 on there, and when you run the software that comes with the logic analyzer, or it doesn't come with it, that you install, you have to download it, it gives me this error message here: possible USB host controller problem detected. And it works, but it doesn't work well. It will time out sometimes and have buffer overruns and things like that. So that they are right. This is exactly what it does. And I also loaded up the same software in Linux. I've got Manjaro Linux running, and in Linux it doesn't have that problem at all on the same hardware. So the latest kernel, obviously, in Linux is better than what Windows 10 is on this machine. And I am in the process of switching everything over to Linux. So and when I use this software, I definitely use it in Linux, not in Windows. So that's an interesting thing here. Anyway, let's continue. Okay, so close this. Now, as I said, in Linux, it works at the full 24 megabits per second, but I know that I have to reduce it a little bit in Windows because of these drivers. Now, if you have a more modern computer, you probably don't have this problem in Windows either. But in any case, let's pick up some signals. Okay, so I just told it to go ahead and zap something here. You can use the mouse scroll wheel in order to spread it out, and straight away you can see when you it's got a grid there: 3.3 milliseconds, 0.4 milliseconds, 0.5, so that you see what the time base, and you can hover over these traces, and it tells me that there is 49.667 microseconds for the half wave, and it is 97.417 microseconds for a full wave of the clock signal. And then of course I pick up these are the 4 BCD digits that it comes up with. So when it is low, see over here, it says low on the bottom and high at the top. And so over here, well, let's start over here. This green signal here is actually the carry. So when it hits, when it goes past 9, it outputs this signal here, so that if you can concatenate, different digits, and that's what that signal is for. But that tells you that it's starting over. So here, so you can just use the mouse hold and drag it and move it over. So here we see this is low. That's like D0, D1, D2, and D3, 3 binary bits. Low, 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 low. So that's 0. And then we see the next clock signal here. D0 goes 1, so there's 1, 0, 0, 0, or that's from the least significant bit to the most significant bit. If you go the other way around, it'll be 0, 0, 0, 1, 0, 0, 1, 1. That's and not 1, 1. Sorry, 0, 0, 1, 0. That's 2, and it's 3, and that's 4, and so on. So it's counting as we've seen it do before. So this is kind of a nice feature, having this on this software. This software is actually quite good, and it is not made by the people that make that little tiny little logic analyzer. They just made it compatible with this software. This company, SELAE or something like that. I don't know how to pronounce it. They make logic analyzers as well, but they tend to cost $300, $400, $500 or more. Not $17 like this one. In any case, it is the software that makes these things good. It's got some device settings there. You can select the analyzer. It has some you can set markers for timing and all that kind of stuff, and it has all sorts of features. And it also is able to see I2C, SPI, serial, like RS-232. You can actually tell it what the signal is, and it'll then analyze it for you and tell you like if it's serial, what the what the binary codes of each character is and all that kind of stuff, the data. You can then save it and so on, and you can look at the data later on and so on. So this software is actually very good. There's another kind of software from another company that when you buy this thing, there's a link, on the but that software does not work on this computer because, as I said, it has some problems with the USB ports and so on. But this software is actually better anyway. So this is the one to get. So anyway, let's close this, and we'll go and check what these little analyzers have in them. Oh, and I forgot to mention the software for the logic analyzer can be downloaded from www.saleae.com, and you can see it on the screen here. You can download it for Windows, Linux, Mac OS X, and so on. So that is where you get the software from for the little logic analyzer. Okay, so another thing to mention with these is that these little guys, they came with these two ribbon cables, which you can certainly, I'll unplug this, you can certainly plug them into the individual pins here, but then they're both females, so I find that very inconvenient. If they had little male pins on the other end, at least you can stick them in a breadboard or something, or connect them to some little plugs. So yeah, so I took a piece of ribbon cable and I put a proper little plug on it, which actually fits into this socket. So which is a much better thing than all these individual DuPont pins on that cable. So and then what I did is I put some heat shrink tubing around here to stop it from fraying apart, and then I pulled the little threads from the ribbon cable apart, and I mounted these little clips on them. So that works a lot better now. Comes with absolutely no information whatsoever, no documentation, nothing. It just gives you a hint to go down to the look for the software to download on somebody else's website sort of thing, which is what I did, and that's the software I showed you. But it has a pin here that says clock or CL cables, but I presume it's clock. I have no idea what that thing is for. When I hook it up to the oscilloscope, it's got like a triangle wave on there, and it was like 2 megahertz or something. But then when you try to hook it into something with a lower impedance, I mean, the signal changes, the frequency changes, and it seems to go to it's not a triangle wave anymore, it becomes like a distorted something, I don't know, some strange distorted wave. So I have no idea what that thing is, but in any case we've been using the ground and channel 1 to 8, and it's been working perfectly with that software, so I'm not too worried about that. I might investigate where that goes to one of these days and see if I can work it out. Okay, so this is the little analyzer under the microscope, and first thing we'll see is a bunch of chips here. This here is a voltage regulator, 33, it's a 3.3 volt one, so the whole thing is running on 3.3 volts, that tells us that. This chip over here, 20-pin chip, is actually just an 8-bit bus transceiver, like so. It's an octal bus transceiver with tri-state outputs, so nothing too special there, it's just like a buffer. And you can see that there are 8 inputs here, 1, 2, 3, 4, 5, 6, 7, 8. That's the 8 data inputs that goes into this chip and comes out, and it goes to this chip over here. That chip over there, we will bring up next, is actually a microcontroller. Easy USB FX2LP USB microcontroller, features USB 2, single chip integrated USB 2 transceiver, smart ISE, whatever that means, enhanced 8051 microprocessor. So 8051 microprocessor has been around probably for 30 years or more. It used to be an Intel chip. Probably been around for 40 years or more. Anyway, I don't know how long it's been around, but it's a very well-known little microprocessor. But it obviously has features for USB, and it has some RAM and all sorts of stuff. And let me see now. This is the block diagram. Has a 24 megahertz crystal. That's why it is rated at 24 megahertz maximum for scanning the input signals. It has data inputs and data outputs, and so on. So this is there's software running in there, obviously, that scans the inputs and then gives outputs to the software on the USB port. And this little chip over here is a 2 kilobyte or kilobit or whatever it is. It's a little EEPROM that probably has the firmware encoded in it that runs the microprocessor. That's really all there's to it. It's fairly simple. There's not much. There's a 24 megahertz crystal there. There's not much else to say about it. Looking at the circuit, so that's pretty much it. I think it is quite useful little device. I mean, for the price, for less than $20, you got 2 of them, and for analyzing logic circuits and stuff, I think it would be very useful. So I think that was a good purchase. Anyway, next, I've got some stuff coming from AliExpress. We're going to be evaluating some multimeters, and a bunch of them. Now I'm purchasing these things myself. I don't get anything from anybody to evaluate for free, so it'll be honest evaluations. And we're going to be evaluating soldering irons and some soldering, desoldering irons, machine devices, and how to use them and stuff in future videos. So keep your eyes peeled for those. Anyway, until then, goodbye.